All right, let's see if we can finish this review in about 30 minutes. I am not going to go over vocab. That is in your notes. You can refer to that for pre-image, image, translation, reflection, rotation, dilation. But I will play the song for you before we get started to help you remember those things. So it says, consider the translation that is defined by the coordinate notation or the rule x plus 6, y minus 4. So it looks like we're going to the right 6, and then we're going down 4. And then it asks, what is the image of 3, 0? And so what is the after? After we go plus 6 and minus 4. Well, our image is going to be at 9, negative 4. And we're asked to do that again. Plus 6 minus 4, and our image is going to be at 0, negative 11. All right. Translate the figure 4 units to the right, so plus 4, and 3 units up, plus 3. So x plus 4, y plus 3. Our pre-image is at these points. Let's start with O. O is at negative 6, negative 6. P is at negative 6, negative 2. Q is at negative 2, negative 2. And R is at negative 2, negative 6. And we need to go plus 4, plus 3. So if we go negative 6 plus 4, we'll be at negative 2. And if we go negative 6 plus 3, that's at negative 3. So our image is going to overlap our pre-image, and that's okay. We'll see what that looks like here soon after we graph it. So now we need to go negative 6 plus 4. We land at the same place, negative 2. And negative 2 plus 3, we're going to land at 1. Negative 2 plus 4 is going to be positive 2. And negative 2 plus 3 is going to be 1. Negative 2 plus 4, positive 2. And negative 6 plus 3, negative 3. So let's plot all of our points. O prime is at negative 2, negative 3. O prime. P prime is at negative 2, 1. P prime. Q prime is at 2, 1. Q prime. And R prime is at 2, negative 3. R prime. We connect our points. In fact, I'm going to change the color so it stands out a little bit. And there is our image. Write the translation rule. This one is tricky. Write the translation rule of point T to point T prime. And so what we have to do is check and see what happened. 10 changes to 0. And negative 5 changes to negative 10. So how does our point move? It looks like we go to the left 10. We subtract 10. minus 10 would get us to 0. And to get from negative 5 to negative 10, we subtract 5. So our translation rule is x minus 10, y minus 5. Find the coordinates of the reflection. Reflect 1, 3 over the x-axis. Whenever you reflect over the x-axis, your x-coordinate stays the same. And then your y-coordinate changes sign. And so if x-coordinate stays the same, we're going to stay at 1, and then our y-coordinate is going to change signs to negative 3. This rule is up on the whiteboard for you to see. When we reflect over the y-axis, our y-coordinate stays the same. And so this will stay negative 3, and then our x-coordinate is going to change signs. Since it's currently negative, it's going to change to positive. Whenever we reflect over the line y equals x, xy maps to yx. They trade places. So that's going to map to negative 6, 4. And whenever we reflect over the line y equals negative x, xy maps to negative y, negative x. This rule is up on the board for you to see. So they're going to trade places and both change signs. So that's going to be 12, 7. Reflect the triangle across the y-axis. So A is at 3, 3. B is at 5, negative 1. And C is at 1, 1. And we just said that whenever we reflect across the y-axis, that our y-coordinate stays the same. And so let's transfer all of our y-coordinates. Those are going to stay the same. And what's going to change is our x-coordinate is going to change sign. Negative 3, negative 5, negative 1. And so where's our image? Let's find out. A prime is at negative 3, up 3. B prime is at negative 5, negative 1. And C prime is at negative 1, 1. And so hopefully you can see how our triangle has flipped across our yellow line. Let's keep moving. So, point H is rotated this should say counterclockwise. This is gonna say counterclockwise to create H prime. Yeah, both of these should say counterclockwise. So we'll fix that, and that's okay. And I'll check those numbers on the test, make sure those are counterclockwise, because our rules all go counterclockwise, but let's continue. Point H is rotated 90 degrees counterclockwise to create point H prime. And so write the rule for 90-degree rotation. A 90-degree rotation in 90-degree rotation, XY maps to negative Y, X. meaning they trade places, and then the first, whatever in this location, changes signs. So trade places first, 5, -7, and whatever right here changes signs. So this is going to be -5, -7. All right, write the rule for a 180-degree rotation. Whenever something rotates 180 degrees, xy maps to -x, -y. And so that means both just stay where they're at, but they change signs. And so that means h prime is going to be at 9, -1. Again, we're going to change this to say counterclockwise. Rotate the triangle 270 degrees. Our 270 degrees, xy, maps to y, -x. So they trade places, and then whatever in this location is going to change signs. So let's get our coordinates. J is at -6, -7. K is at -6, -2. L is at -3, -7. And so let's trade places. -7, -6. But let's go ahead and as we trade places, change the sign here. So instead of -6, this is going to be a +6. Or you could write +6 if you'd like. But I'm just going to remove the negative. All right, let's try that again. These are going to trade places. So what's going to come first? 2 or 6? Our -2 comes first. And then our +6 is going to come here. And we have a -7, +3. Let's graph our points and see where our triangle lands after we turn it 1, 2, 3 times. So -7 up 6, J prime, -2 up 6, K prime, -7 up 3, L prime. So now we're transitioning into the topics we've been learning about this week. Similarity. Two polygons are similar if their corresponding angles are congruent and their corresponding sides are proportional. So we have congruent angles, proportional sides. That's how two polygons can be similar. And similar means same shape, different size. So given these quadrilaterals are similar, given that they have proportional sides, find the value of x. So we're going to set up a proportion. X, which is side PS, PS is going to go with TW. X over 15 is proportional to, if I started in this polygon, I have to come back to that polygon. And the only side that I have to pick is SR. And SR goes with WV. So I'm going to put 35 over 25. and we're going to cross multiply. $25x equals 525 divide by 25 on both sides. And we get 21. All right, here we have a word problem. The sides of a triangle are 9, 15, and 20. Find the length of the shortest side of a similar triangle whose longest side is 40. So we're going to put shortest over shortest. So we want to find the shortest side. We don't know it, so let's call it x. X is our shortest side over our shortest side, 9. And we're going to put largest, 20, over largest, 40. And let me double check and make sure I did that right. I did not. Largest, 40 over 20. And so let's talk about that, why it wasn't right the first time. We have our small triangle, and we want to keep our small triangle on bottom. And then we have our similar triangle, and we want to keep our similar triangle on top. So there's an unknown side in the similar triangle, and there's the largest side in the similar triangle. And we want to keep both of the similar triangle sides on top. So that's why we had to fix that. So now we're going to cross multiply. 9 times 40 is 360 equals 20x. Divide by 20. And we find that x equals 18. And so the length of the shortest side of the similar triangle is 18. All right, let's move on to our next problem. This one's a tricky problem. James is 140 inches tall. He's standing 320 inches away from a lamppost. His shadow from the light is 80 inches long. How high is the lamppost? So a lot of us understand that x over 140 is going to be proportional to something over 80. But a lot of us want to put 320 over 80, and that's just not the case. We have to take the entire side length of this triangle, and the whole side length, when we add the two pieces together, we get 400. So let's cross multiply. We're dealing with really big numbers, but that's okay. 80x equals 56,000. We're going to divide both sides by 80. And we find that x is 700. That our lamppost is 700 inches tall. All right, now this one's easy. Height over height equals shadow over shadow. I'm not even going to read the problem. Let's just get started. Height over height equals shadow over shadow. And we cross multiply. 12 times 5 is 60 equals 3 h, divide both sides by 3, and we find that the height of the building is 20 feet, about 2 stories. All right, now we're asked complex problems. Are the polygons similar? Meaning, do they have, we got to check for 2 things. Do they have congruent angles? And do they have proportional sides? We got to check for those 2 things. And so first, the angles. We got right angle, 30 degrees, 30 degrees, 60 degrees, 60 degrees. So they have congruent angles. That's great. Now let's check and see if the sides are proportional. I'm going to take shortest side over shortest side, and let's put new over old. So short over short would be 8 over 16. Medium over medium would be 15 over 30. And longest side over longest side is going to be 17 over 34. This simplifies to 1/2. This simplifies to 1/2. And this simplifies to 1/2. Our scale factor is 1/2. And since they're all equal, yes, we have proportional sides. Yes, we have congruent angles. So let's write a similarity statement. Triangle TPN is similar to triangle GKR. Which of the following triangles are always similar? There's 2 kinds. Equilateral triangles are always similar because they always have proportional sides. So here's 2 equilateral triangles, 60, 60, 60 in both. So that's the congruent angles. And then the proportional sides, if this was 6, 6, 6, and this was 7, 7, 7, 6 over 7 would be 6 over 7 each time. So equilateral triangles are always, always, always similar. Not only are equilateral triangles always similar, but isosceles right triangles are as well. Not right, not isosceles, but isosceles right together, okay? Determine how the triangles can be proved similar if they are similar. Complete the similarity statement. So, we are given information on what in these triangles? Are we given information on the angles or on the sides? We are given information on the sides. So, let's check and see if the sides are proportional. All right, here's our new. Here's our old. We're going to put shortest over shortest. And so that's 8 over 48. 12 over 72. And 14 over 84. And see how they compare. they all simplify to the same fraction. So yes, our triangles are similar, but how are they similar? Are they similar by angle? Well, no, we were not given any information about the angles. Side, side, side. It looks like we have 3 sides, pairs of sides that are proportional. So yes, this is side, side, side. So if we finish the similarity statement, triangle CBA is similar to triangle, well, C is the vertice between the longest side and the shortest side. So between the longest side and the shortest side in the other triangle is going to be F. All right, so we're going to go from C to B. So we're going to go from F to G. F, G, H. All right, let's do this again. Here we're only given information on sides. Let's check and see if the sides are proportional. Shortest over shortest, 15 over 42. We're going to compare that to 25 over 70 and compare that still to 30 over 84. Turns out all of our sides are proportional, so we have another side, side, side similarity. And triangle TUV, T is between the medium and the shortest. So between medium and shortest is Q. TU, we're going to go QRS. All right, let's keep trucking along. Here, we have vertical angles. That's the first thing I see. Now let's check and see if the sides are proportional. All right, if the sides are proportional, then we're looking at side, angle, side similarity. So we're going to take the shortest side and put it over the shortest side. So that's going to be 8 over 28. And compare that to 14 over 49. Eight over 28, my bad. All right, we have these sides that are proportional and a pair of angles that are congruent. That's enough information to say yes, the triangles are similar by side angle side similarity. All right, here we have a congruent angle. And now let's check these two sides. Short with short, long with long. Let's check and see if the sides are proportional. 9 over 21 and 18 over 42. (18 over 42 reduces to 9 over 21. 9 over 21 does not reduce. It's just 9 over 21. Let me see. I'm actually incorrect there. Let's try that again. 9 divided by 21 is 3/7. And so 18 divided by 42, we get 3/7. Either way, we're coming to the same conclusion. Our sides are proportional. They are similar by side angle side. All right, determine how, if possible, the triangles can be proven similar. So right now, I'm only seeing one angle, and we're not given any information on side, so we can't use side or side angle side. But we got to check and see. We have to be thorough to see if it's angle. And so right now, there's only one angle. Let's find this missing angle to check and see if it's angle. So we're going to add the two angles that we have, 92 plus 57. And I'll subtract that from 180. Let me make sure I added correctly. All right, we get 31, and unfortunately, 31 does not match 41. Therefore, these triangles are not similar. Well, that's the end of our review, and I believe I've made it in under 30 minutes. So thank you for working through your review with me. It was lightning fast, and you get to use your review on your test. So yeah, good luck on your test tomorrow.